section 4.5 is integration by substitution, and the first thing we're going to do is we need to make sure that you understand how these problems are different from what has come before it. So we're going to look at the example, the integral from 3x minus 5 to the fourth power with respect to x. Normally, we can't integrate parentheses to a power. If we have parentheses or multiplication or division of any kind, we have to distribute first, right? Well, that's going to become a problem when we have parentheses to the fourth, fifth, sixth powers, or even if we have parentheses to a 1/2 power, because there's no easy way or no way at all to distribute those. So distribution is out. So we have to figure out what we can do to make this work. And the key to understanding this is sort of like the chain rule for integrals. When you take the derivative of a parentheses to a power, what's the very last thing you do? You multiply by the derivative of the inside. So in the most basic of terms, it should work if we first divided by the derivative of the inside. But it does have some limitations. And those limitations are you can only divide by things that aren't variables. And then there's some other stuff too that kind of plays into it. So it's just thinking of it that way is kind of difficult. Okay? So we're first going to look at it just by substitution, and then I'll show you kind of a shortcut that'll work. Basically, if this were just x to the fourth, I wouldn't have this problem. I would just say it was x to the fifth over 5 plus c, right? Mm-hmm. So let's see if we can figure out a way to turn 3x minus 5 into a monomial. And what we do is we just make it up, and we come off to this side, and we say, all right, we're going to let u equal 3x minus 5. So we're just going to make up this new variable, u. And that is standard across all of calculus. This is called u substitution. So if you're going to make a substitution, a binomial or trinomial into a monomial, you'll let u be what that is. So you're going to let u be the inside of the parentheses. Then what you're going to do is you're going to take the derivative of u. And we're going to do it in differential form. So instead of u prime, we're going to do like du dx, okay? So we're going to take the derivative of u with respect to x. And we're going to say that du dx is equal to 3. Do y'all agree with that?
Yep.
Okay. Now I want you to solve that for dx. I want you to get dx by itself. So we have 3 dx, we'll cross multiply, is equal to du, and dx is equal to 1/3 du. So here's what we've done so far. We have taken our binomial that's causing the trouble, the parentheses to the power. We have substituted u for it. We just made that up. Then we also have to substitute something for the dx. So we took the derivative of our substitution here, and we said du dx equals 3, and we solved it for dx. So what we're going to do now is we're going to come back over to this problem, and we're going to make those substitutions. So instead of 3x minus 5 to the fourth, we have u to the fourth. And instead of dx, we have 1/3 du. So I want to get rid of all my x's. I want them to become u's. So I replace this piece with u and this piece with 1/3 du. And I'm going to clean that up. And because that 1/3 is sitting in an awkward spot, I'm just going to bring him to the front. And we can bring him all the way to the front of the integral, or we can put him just inside the integral. I prefer just to bring him to the front. So we're going to bring him out here, 1/3 times the integral of u to the fourth du. At this point, we can integrate. We don't have parentheses to a power anymore. And so that will just become 1/3 times u to the fifth divided by 5, right? So over here, we have 1/3 u to the fifth divided by 5 plus c, because it is an indefinite integral. So now we have u to the fifth over what, 15 or 1/15 u to the fifth? All right, so this is a lot of work. I don't know about you, but this looked like such an easy problem, and it seems like we've done 15 steps now. And you can't stop there. You can't leave it as u's. You made the u up. You don't get to just change the variable and leave it. You now have to change it back to x's. So instead of u, we're going to now put back our parentheses. Yeah, okay. So we're going to say that's parentheses 3x minus 5 to the fifth over 15 plus c. And this is our final indefinite integral. if we took the derivative of that and applied the chain rule, we would have our original function back. Do you have any questions about that so far? No? Why don't you try the next one using U substitution on your own? We'll pause, and after we do these two, I'm going to try to talk you through the shortcut. So we'll do these two by substitution. That way, if you ever get stuck, you're not sure of the shortcut, you can do it this way every time. But I think that most of you will be able to see the shortcut and do it without the whole like UDU stuff. But try this one by substitution. Okay, so for this example, we have a parentheses squared. And so since we can't integrate a parentheses squared, what we could FOIL it out. You guys understand that, right? Yeah. Like that particular one, we could FOIL it out just as easily. And that would probably be what I would do, in that case. Just FOIL it out and be done with it. But for the sake of what we've been doing, it should work by substitution as well. So we're going to come over here and we're going to let u equal 2 minus 5x du dx, du dx equals negative 5. So dx equals what? When you solve that? Negative 1/5 du?
Yeah.
And then I should have what I need to make the substitutions. So I'm going to put this in the place of dx and this in the place of 2 minus 5x. So I have 2 minus 5x is u squared times negative 1/5 du. And just to make this look a little less awkward, I'm going to factor it to the front. And add 1 to the power, divide by the new power, because now it's a monomial and we can do that. So we now have negative 1/15 u cubed, right? So that's u cubed over 15. But we can't stop there. We have to resubstitute, get rid of the u's, and we have 2 minus 5x to the third. There's a negative out there, over 15 plus c. We're out of room. So what do you guys think about that? It's ugly, but it's not bad, right? Okay, so I'm going to stop here. Then we're going to rework these same two problems, and I'm going to try to explain a shortcut method to you that will work not on all of them. That's the problem, but on most of them.